Hello, everyone. Welcome to the Flow Waterjet webinar. We are just getting started. Bear with us for 1 minute, and we will be ready to go. Okay. Well, happy Wednesday, everybody. If you're here for the Flow Waterjet webinar on 10 critical factors you can't ignore when considering Waterjet, then you are in the right place. I would like to remind you of a few housekeeping items today. First of all, we are live. We are at our kitchen tables at some of our offices in our homes and in our workspaces, and we are very happy that you've decided to join us, and we hope you find today very valuable. Along with being live, please know that since there are so many attendees, we have muted all of the outside microphones. We have also disabled, we have also enabled our chat function, so you can continue to chat interactively with us. And if you would like to provide your name and contact information and further questions when we get to the Q&A section, please feel free to do that in the chat box that is on your screen. However, only the folks working behind the scenes will be able to see them. Also, please note that our contact information is available, and we will be sharing more with you at the end of the presentation. We've scheduled the time for this to run for about a total of 45 minutes to an hour at the very most, but with ample time allowed at the end to cover as many questions as we possibly can. So I'd like to start by introducing you to our Waterjet experts. Conducting the seminar today will be Duncan Murdoch and Bruno Cicciarello from our Flow team. Duncan's our regional business manager and has more experience in the tip of his little finger than most of us all put together. He's an expert subject matter resource for us across everything in the Waterjet business, and has had several patents and has been, as I mentioned, in the industry for many, many years. And we're thrilled to have him on our team and here to share all of his knowledge. And not to be sold short is our co-presenter, Bruno Cicciarello, whose specialty is in applications engineering. Bruno's been with us for over a decade in a lot of different areas, and in particular to the Waterjet software and application side of the business. His skill set is a great complement to Duncan's and to all the rest of the Flow team. So the two of them are going to take us through the 10 critical factors that you should be thinking about if you're considering Waterjet. And again, we can't hear you, but we can take your questions via chat and are looking forward to answering those at the end of the presentation. So without further ado, gentlemen, Duncan, Bruno, thank you, and please take it away.
Thank you very much. This is Duncan, and first of all, I'd like to ask for your patience. The last time I did something like this was in the 4th grade when I was Santa Claus in the Christmas show. And the only reason I got that role is because I was the only one small enough to fit in the costume.
That's a great story, Duncan. There's no way I can match that story, but I just want to share that I'm very happy here presenting this with you, and we're happy that you're here joining us as well. Thank you.
Okay, let's get started. Buying a piece of capital equipment should not be taken lightly. This is a purchase that could impact your business, will impact your business for many years. This webinar is designed to help guide you through the process. First factor we're going to discuss is, what are you going to be cutting? Abrasive Waterjet is a cold cutting process. It's highly versatile and flexible, and for the most part reduces secondary finishing. Waterjets can pretty much cut anything from tissue paper to carbide, with the exception of tempered glass. In fact, if you sit in your car and you look at the dashboard, you look up at the headliner, or you look at the carpet, those are all Waterjet cut. If you stop at McDonald's and have a chicken McNugget, that's most likely cut with water also. And if you like fig Newtons, we cut those too. So the next video we're showing is cutting a number of different materials with our abrasive water jet. It's coming up now. We're cutting aluminum, stone, carbon fiber, glass, and stainless steel, and titanium. The neat thing about this is that we're cutting this all with the same tool, which means we're using the same orifice and water jet, orifice and mixing tube combination, which means that when I change or you change from any of these materials, all you're doing is changing the speed. When cutting soft materials, such as materials that you can cut with a pair of scissors, we use water-only cutting without abrasive. In this video, it's showing us cutting some foam, but you can cut anything from tissue paper and baby diapers to foam, gasket materials, rubber, and even some thin composites we cut with straight water. When cutting harder materials and brittle materials, we use abrasive jet. The way an abrasive jet works is we take high pressure water anywhere from 60 to 94,000 psi, and we run that through a small orifice, typically in the neighborhood of 10 to 15,000 inch in diameter. We convert, when it goes through the orifice, it converts from high pressure water to high speed water. In other words, we can get a velocity of that water anywhere from 3,000 to 4,000 feet per second, depending on the pressure. What we do then is we entrain the abrasive into that stream, and we use that high-speed abrasive to erode through the material. And if for some reason you need to cut the material that's either brittle or has a tendency to delaminate, we have a system to allow you to cut or pierce at low pressure, then bring the pressure up and finish the cut. That's called our ultra pierce technology. Take it away, Bruno.
Thank you, Duncan. Factor 2, what size and thickness is the material you will be cutting? So you need a system that will hold the largest material size you use most often. Most systems are going to range anywhere from 4 by 4 foot and up. Most popular sizes include our 10 by 6.5 and our 13 by 6.5. These two particular sizes will allow you to place a standard sheet of material, whether steel, 10 by 5, or aluminum, 12 by 4, and other materials. Our 26 by 13 allows you dual cutting zones, which means you can maximize efficiency by placing 2 sheets of material on the table, and when one side is doing the cutting, the other side you can be loading and unloading material. Mach 700, this is one of our engineered to order machines. They are designed and built in any configuration and size for high production environments. This particular image shows a 78 by 16 foot machine with dual bridges and dual masts. When it comes to the Z height, our standard sizes are 7, 8, and 12 inches. Also, 24 inch of Z travel is available on select models. We have a customer in Europe that is currently cutting 20-inch thick material utilizing a 12-inch axis. So you're not necessarily limited to normal Z-axis capabilities.
Oh, looks like we might have lost Bruno's sound there for a second.
Am I on?
There you are. Go right ahead. If you could repeat what you just said, Bruno, that would be terrific.
Sounds great. Thank you, Steve.
Mm-hmm.
So factor 3, what level of precision do you need? What kind of work will you be completing? Water jets vary in the precision they offer, plus minus 5 thousandths of an inch to plus minus 12 thousandths of an inch. So it is important to consider how you might use your system when determining the right fit for you. So whether you are a machine shop supporting aerospace industries, a fab shop cutting multiple materials, a stone shop, or a machine manufacturer, you're going to be able to hold specific tolerances. Looking at this image, you can see that taper and stream lag is inherent to any water jet cutting process. As you can see, as the water exits the nozzle, it has a taper. And as the head moves, the jet will follow. This is called jet lag. We have a video here of a water jet cutting through glass, which is going to show that lag a little more clearly. As you can see, the head is moving forward and the stream is going to follow. So controlling this taper and jet lag is a critical part of controlling tolerances and cutting high accurate parts. There are two ways in where I can achieve this. If I'm using a standard head, I can slow down the speed of the cut. The slower I go, the smaller the taper. Or if we have a dynamic water jet head, which the next video will show how this works. So as you can see in this particular video, the head is continually moving. What's happening is that head is compensating for the taper, and it's putting all that taper to the scrap side of the material. What this means is I have very minimal taper, top to bottom, maybe plus minus 1 thou to 3 thou, and then I can cut much faster while keeping very tight tolerances. These are two images of our standard water jet head, invented back in the 1980s, and our patented dynamic water jet technology. Factor 4, do you have a need for bevel, chamfer, or 3D cutting? So in addition to the pure water jet, standard water jet, and dynamic water jet that we just saw, we have two 5-axis heads. One is our Pivot Plus, and the other one is our Dynamic XD. Pivot Plus, although capable of cutting very accurate 3D parts, it was designed with weld prepping and beveling in mind, up to 52 degrees of angles. It is durable, compact, and streamlined. It also has taper control. Now, for applications where more accuracy, speed, and greater angles are required, we recommend our Dynamic XD. This particular head combines high precision 3D cutting with our patented dynamic water jet technology. Both heads will compensate for taper on 2D and 3D. So we have a story here. We cut a part, a test sample for one of our customers, and it was a very intricate part. We had to cut 36 holes, 1/8 inch diameter at 30 degrees through 1-inch steel, if I remember correctly. Duncan, do you remember the tolerances that we were supposed to hold on that part?
Oh, yes, I do. It was plus 2 thousandths, minus nothing.
Yeah, so very tight requirements. And so there we are with the part in hand, waiting for the customer to come up, and we get the QA manager and the machine shop supervisor. They have a box with pin gauges. Duncan and I looked at each other, sweat is pouring down our foreheads, but the part was perfect. Factor 5, consider the usability and capabilities of your software. You need software that is intuitive and easy to use as it is powerful. Your software should allow your operators to start cutting as quickly as possible. All flow machines are available with a powerful suite of software. With our software, you can virtually open any file extension, whether it's a 2D or 3D file. Your operator will be able to draw and import a model and create a path for the machine to run in no time. So remember, smart software equates to a smart part. 3 things that your software should do. 1, draw, design, import your part, set an efficient path for your machine to follow, and calculate the algorithms that determine how to cut your material. This video shows a part being modeled in Flow Expert. This is our 2D and 3D CAD/CAM package. You'll notice how quickly and easily we can create a part and then path it for machine operation. Some of the features that are included in this software are import and export virtually any file extension. You can create 2D, and 3D models. It also has a repair tab, which will allow you to quickly review and fix your files before sending them to the machine. It also has a sheet metal module in which you can draw, import sheet metal parts, then you can unfold these and create that pattern running in the Waterjet. The sequence tab will allow you to bring that model in, select the surfaces, select path, and the machine will automatically, or the software, sorry, will automatically create that path for you to run in the machine and can be cut in virtually no time. With that, I'm going to send it back to you, Duncan.
Thank you very much, Bruno. The next factor, factor 6, is how will you be running your Waterjet? What are your production needs? Your needs differ if you're running your system for only a handful of hours a day versus a 24-hour shift. Production needs often inform your pump selection. There are two types of pumps used in Waterjet cutting. Every Waterjet system needs a pump. And the two systems that we have are both a direct drive and an intensifier style pump. Flow International offers both direct drive and intensifier pumps anywhere from 30 horsepower to 200 horsepower. So we have a pump that will fit your needs. First, I'm going to talk about the direct drive pump. The direct drive pump is a positive displacement crankshaft pump. It's really similar to the pressure washer you probably have sitting in your garage. It's a crankshaft driven piston pump where we pump pistons at 600 RPM and run that through a set of check valves and out to the cutting head. This pump is designed to run at maximum pressure and maximum flow rate all the time. Although with our patented PAC-V pressure control valve, you can run at lower pressures or lower flow rates. In other words, run a smaller nozzle. But as far as your pump choice, this is a pump that you would choose if you're running on a one-shift basis and doing a lot of abrasive jet cutting with a single nozzle combination. Next pump design I'd like to talk about is the intensifier pump. This has been the industry standard for a long time, basically since we started here in the mid-70s. This is a hydraulic over water intensifier pump where we have a large hydraulic biscuit coupled to two small pistons, where when we put the high pressure hydraulic oil on one side of it, we get even higher pressure water out the other side on the small piston. We suck the water in on one stroke and push it out through check valves on the other stroke. Because this is a hydraulically driven pump, it is extremely versatile with the fact that because it's run with the hydraulics, you have the ability when the pump, you run lower pressures or smaller nozzle sizes, the hydraulic pump goes off stroke a little bit.
Sorry, I didn't quite catch.
And goes off stroke.
Sorry, I didn't catch that. Try tapping above to edit.
Pump goes off stroke and stroke slower, making it very versatile. So if you were running a system or have a business where you do a lot of Waterjet, abrasive Waterjet cutting at high pressures, you do some low pressure water only cutting, or in the instance of our 24-hour day operations, you're going to need an intensifier pump. In fact, all of our 24-hour day operations cutting tissue paper, baby diapers, and chicken use intensifier pumps. Now we've taken this pump, the 60,000 PSI pump, and we've moved it up to 94,000 PSI over the last few years. And what's happened here is that we've brought ourselves up to the much higher speed cutting. So in other words, when I talked earlier about the 3,000 to 4,000 feet per minute cutting speed, well, when you're at 94,000 PSI, that jet speed that comes out of the nozzle is about 4,000 feet per second, which allows us to cut with garnet that's running much faster. So if we hit the material with a piece of garnet traveling 4,000 feet per second versus a piece of garnet traveling 3,000 feet per second, it's going to cut much faster. And in fact, what we've done with this technology is we've been able to cut faster and also reduce garnet use considerably, up to 30%. The neat thing about that is the fact that the largest amount of cost in a Waterjet cutting is the abrasive cost. It's about 60 to 70% of your cost. We're going to show you a video now showing a 94K cut overlaid with a 60,000 PSI cut. And you can clearly see the difference in speed between these. What you can't see is the amount of abrasive used. And because we're cutting faster and using a less abrasive, we get kind of a double dip there. And we're going to be able to cut much faster with less abrasive. The neat thing about this is that you're probably going to charge the same amount for that part, whether it's cut at 60K or 90K based on industry standard pricing, but you're going to be able to cut it much faster and make a lot more money. Here it goes. Watch the video coming around here. Here comes the 90. This kind of tortoise and haircut thing here. So as you see, the 90K cuts 26 seconds, takes 0.48 pounds of abrasive. And as we're waiting here on the 60K to come through, you're going to see that it's going to come through and cut in, come on. Here we go. "38 seconds with 0.72 pounds a minute of abrasive." So you can see that again, you're going to cut faster and make more money with 90,000 PSI. Factor 7, purchasing a system for reliability and longevity. Machine design and construction matters. It not only plays a large role in your cut parts, but also in the total life of your system. The flow line of cutting products are built with quality as a top priority. All of our weldments are welded per ASTM specs and thermally stress relieved for 24 hours to achieve maximum stability. Our THK ball screws and linear ways are mounted on machine surfaces and laser aligned. Total machine weights exceed 15,000 pounds on all but our smallest models. We use turn the nut technology, which is that we fix the ball screw and turn the nut to ensure high accuracy and the highest acceleration possible. We also use matched Yaskawa drives and amplifiers located at each axis and EtherCAT communication for increased signal speed and repeatability and reliability. We also use a high pressure whip system to deliver the high pressure water to the head. This reduces your pressure drop and also reduces your swivel maintenance. We at Flow have had machines running in the field for over 30 years. In fact, quality has always been our top design feature. We, in fact, if I had a nickel for every time a customer said, "I'd buy a new machine, but this one keeps running," I'd probably be retired by now. I'm going to send it over to Bruno.
Thanks, Duncan. Okay, factor 8, consider system ergonomics and your operator's convenience. Making sure your operator can quickly, efficiently, and ergonomically operate your Waterjet is an important factor that cannot be overlooked. So equipment designed with ergonomics in mind will improve your overall productivity and safety. So with this concept in mind, we have made key improvements to our equipment. Tank height is at the appropriate height. What this means is that you can comfortably load and unload material. The toe kick panel, this will allow your operator to get very close to the tank, eliminating overextension when unloading parts or material. We have a roll-around console, and you can get very close to your head when you're setting up your material so that every cut is right every time. We also have added material fixture holders so that we can clamp down the material and ensure that we're cutting great quality parts. Also, in this system, as you can notice in the picture, the gantry or the bridge is on the long side of that axis. So what this allows is for easy load and unload of material from all different sides. Factor 9, how will Waterjet complement your other technologies? So like any other process, the Waterjet can replace plasma, laser, milling, routers, and EDM for many applications. Most shops find that Waterjet complements their existing technologies. Again, the plan here is to bring in another piece of equipment to your shop so that you can complement your existing technologies and become more efficient. So some technologies are good at specific applications. With a water jet, you're gaining versatility. You can virtually cut any material at any thickness, ferrous or non-ferrous, highly refractive, soft materials, stone, glass, you name it, we can cut it all. It also has a very smooth finish, anywhere from 80 to 125 RA. And there's no need for secondary operations. Again, for these factors and for being very accurate, you can use the parts as is, straight from the water jet. Duncan, sending it back to you for factor 10.
Yeah, factor 10, find the right team to partner with you for the lifetime of your water jet. A water jet may be one of your biggest capital expenses. It's important to select a company and technology combination that will support you for the life of your systems. With multiple levels of support, we've got you covered. Anything from our 24-hour-a-day, 7-day-a-week customer and technical service hotline to the fact that we have over 50 technicians located in North America, to also the comprehensive packages we have. We have exchange programs, consumable packages. We also have high-quality abrasive available, extended warranties, and the crown jewel of our service and support is our Flow Care Complete system, where we will actually come in and maintain your equipment for you and provide you with the necessary consumable parts to maximize your uptime. Okay, I want to go over the 10 factors just to kind of let you know, remind you of what we've done here. First factor is what material you're going to cut. Second factor is what size and thickness of the material will you be cutting. Third factor is what level of precision do you need and what kind of work will be completed on the water jet. 4, do you have a need for bevel or 3D cutting? 5, consider the usability and capabilities of your programming software. 6, how much will you be running your water jet? What are your production needs? 7, look for a system built for reliability and longevity. 8, consider system ergonomics and your operator's convenience. 9, how can WaterJet complement your other machine technology investments? And 10, consider finding the right team to partner with you for the life of your water jet. Thank you for your time.
Thank you, gentlemen, and thank you everybody who's been listening patiently and hopefully learning some new and good information about how to inform the choice you make when you're shopping for your next water jet or what you can do with the one you have. If you can bear with me for 1 second, we are going to switch over to Q&A, and the first question is going to go to gentlemen. Well, this is one of the most popular. Okay. How much do these things cost? And can you give us a very common question among our attendees? What can I expect to pay for a typical water jet? What is our range of costs? And what are some of the factors included in that cost? Who'd like to take that one?
I can take that one, Duncan, if you're okay.
Oh, yeah.
Great. So we have a wide variety of machines ranging from different sizes, different configurations, different heads, different pumps. So the price is going to range based on the options that any machine may have. I would say safely we can look at one of our Mach 100s at a 4x4 would probably start in the 90 to 100K range, and they go all the way up to 500 plus, again, depending on size and configuration of system.
Great. And a follow-up to that is actually, can I get a quote? We've had several requests. So that's the sort of question we love to hear. Bruno, do you want to just address that real quick?
Absolutely. So you can contact us. You can contact our main office. Here, Duncan, as part of the sales team as well, we can put you in touch with the right representative, and we can keep this conversation going.
Yes, and in fact, let me help with that. You should also be able to see at the top of your screen on the upper right corner, contact for our main number and an email address. However, during the course of the Q&A, as I mentioned before, feel free to input your name and your contact information, and we will collect those after this presentation is over and distribute them to the right folks within Flow to reach out to you immediately or as soon as we possibly can. So we would love to provide quotes to anybody who needs one. So I'm going to shift gears to another group of questions that are about pumps. And the questions are, number one, what do I need? How do I know what I need? Is it more expensive to run a high pressure pump? And what are the advantages? And then maybe Duncan, this is a good one for you, and I can follow up as you answer.
Okay, yeah. First of all, when you talk about what the pump you need, it really depends on, number one, what you're going to cut, and number two, your facility requirements. I mean, if you take a look at our pumps, if you're going to be mainly abrasive jet cutting, in other words, you're going to cut metals and what have you, say in a fab shop, and you're doing it on a one shift basis, with not a really high production needs, and then the direct drive pump is a great choice. If you're going to be doing a lot of cutting and you need a lot of production, you're going to be varying your nozzle sizes and what have you to accommodate what you're doing, then the intensifier is a much better option.
Great.
So part of that question was?
Yeah, so two follow-ups to that. One, what are some of the what is the impact of using a 90K pump? Specifically, if it uses less garnet and if it's faster, does that mean that there's going to be less garnet deposit in the material? And what is the impact of using a 90K pump?
Well, the impact of using a 90K pump is, number one, the main advantage is the fact you're going to use less abrasive. I mean, everybody knows it in the abrasive world that's the major cost. It's 60 to 70% of the cost of your fixed running costs. So if I can reduce that by 30%, I'm reducing my cost per part. And I couple that along with the fact that I'm going to be cutting faster, then my part cost is going to be reduced considerably, which again means I'm going to be able to make more money on that part.
Absolutely. And then on the flip side, is there a disadvantage to using the highest pressure vis-a-vis? Does it have an impact on the life of the nozzle? And does the abrasive get pulverized at a faster rate when you use the higher pressure?
Actually, you would wear the nozzle out faster if we ran more abrasive through it, but when we calculate the amount of abrasive we use per the nozzle and the pressure, we want to run our equipment at what we call peak efficiency. So if I ran more abrasive through that nozzle at 94,000 PSI, I would wear that nozzle out quite quickly. And that would be an additional cost for you. So that's the reason why we run the abrasive that we have. So we kind of balance, we want to balance all the factors out to make sure that we have the lowest cost per part and the highest profit per part. So it's kind of a balancing game that over the years and years and hours of testing and what have you, we've come up with. So all of our systems, no matter if they're a direct drive running a 13 mil nozzle or 15,000 and 94,000 PSI, the abrasive use that we attach to that combination is running that particular combination at peak efficiency.
Great answer, thank you. So we're going to switch topics over to cutting heads. There are a variety of questions coming in around cutting heads. And first is a little clarification on the difference between our XD and the Pivot Plus, and a couple follow-up questions to that. So who'd like that one? Bruno, maybe?
Sure, I'll take it. Thank you.
Mm-hmm.
So yeah, Pivot Plus, it's available for a Mach 200. That's one of our machining in our series. And the XD is available for the Mach 500 and 700. Now, when it comes to performance, they're both going to be able to cut 3D parts very cleanly and very efficiently. But if you're talking about capabilities and you need to exceed a certain angle, let's say you need to cut anything over 52 degrees, then that's when the XD would be the right choice for you.
Great. And a follow-up with that is, let me see, where did we go here? Sorry, folks. So here's a very specific question. What is, depending on the cutting head, what is the smallest size hole that we can interpolate? What's the smallest size hole we can actually cut?
Duncan?
No, I'll take that. Well, it does depend a little bit on the nozzle combination, but we have mixing tubes where the abrasive goes through down to about 15 thousandths of an inch, which would allow us to cut a hole probably in the neighborhood of around 40 thousandths is our minimum. But one of the advantages to an abrasive jet over the thermal cutting is that we can actually cut a hole that's smaller in diameter than the thickness of the material, which cannot be done with any thermal cutting process.
Great. Okay, so the next few questions are around service and parts and maintenance. So the first question is, how long does a typical water jet last? And Duncan, maybe this is a good one for you, and I think it's a good viewpoint to talk about not just the table itself, but the various components of an entire system, since the water jet itself doesn't just run in a vacuum.
Yes. First of all, let's talk about the pumps. Our 60K pumps were designed in the mid-1970s, and every improvement that we made to that particular intensifier pump has been retrofittable up until now. So we have pumps that we purchased and run, especially with Kimberly Clark, our largest customer, cutting baby diapers, that have hundreds of thousands of hours on them, and they're at current revision level. Now, on our machine tools themselves, our gantries and what have you, we really ask for a minimum 15,000 hour life from our vendors and for the people that supply us with the ball screws and what have you. We want to be certain that we can get 15,000 hours of life out of it, which is about 7 years runtime before you have to replace them. But again, we've got machines, I've got machines in our territory that are 30 plus years old and still running with hundreds of thousands of hours on them.
Great. And following up to that question, can you talk a little bit about our service network and what the expected times are around response time to get a service rep in to take a look at a machine, possibly make a repair? Do we have folks in the field, or how does that work if I'm a customer and I need flow?
You know?
Sure. Well, so at Flow, we understand productivity is key, right? That's what's keeping your business going. So we have many ways of getting parts to you. So you can call us, you can order online. We also have an app where you can communicate with us to order parts or technical support, customer service, any questions we can get there. As far as service goes, as Duncan mentioned earlier, we have 50 plus technicians in the US. And more so regionally, we've created these regional pods where we have, a certain amount of technicians taking care of a particular territory. So this is going to ensure that we can get to our customers much faster and at a lower cost.
Great, great. So a potpourri of questions here. The next question, I was hoping this one might come out is, how come the fig Newtons and chicken nuggets don't get soggy?
I'll take this one. You have to understand that the flow rate of water through a very small nozzle, when you're talking about a 4,000 or 5,000 inch nozzle, is very, very low. Now you remember that you've got a stream that's running at maybe 6/100ths of a gallon a minute, traveling at 3,000 feet per second. And it crosses, say, a fig Newton at 100 feet a minute. There's not a whole lot of time for that water to stop and get something wet.
You sure about that?
Absolutely.
Terrific. Thank you. So a couple more questions that are being asked by a number of people. Can you tell us more about where our water jets are made?
Sure. First of all, we're a company that's based in the United States, and we're a worldwide company. As a matter of fact, we're what's known as a net exporter. We're proud of that. We actually export more of our product outside of the United States than we do sell in the United States. That being said, we have manufacturing in the United States, we have manufacturing in Canada, we also have manufacturing in Europe, and we have manufacturing in Asia, so we can fulfill the needs of all of our customers.
Terrific. Thank you very much. So next question, can you talk a little bit about stacking materials? How do you do it? What are the limitations? How do you know it's going to work? What are the best practices, and how does that impact the height on the z-axis? Or how is that impacted by the height limitations on the z-axis?
I'll take this one. Well, stacking materials is usually done when you're cutting thin materials like thin sheet metals and what have you. And basically you can stack the material until you hit what I call the point of no return, so to speak. In other words, when we get to a thickness where our part cost exceeds the part cost. So typically a rule of thumb on steels is you're talking about 600 thousandths thick. Once you get beyond that, you start losing efficiency of your jet. So the way you stack it up is you just lay it on top of each other, and the stiction of the water between the parts usually holds it shut. On small parts, you might have to clamp it. But typically, stacking over 600 thousandths of an inch is not a good idea.
Got it. Okay, great. Thank you. So a couple of questions on the subject of what we think of as basic requirements surrounding utilities and water and configuration. And the questions are, if I'm getting a new water jet, how do you work with me to ensure not only that I have the right power and water and space, et cetera, to align with the specs, but also the physical configuration of the machine and the space? How do we know that when we unpack the box that the plugs are going to be in the right place, drainage, weight, et cetera? A lot of questions rolled into one, but maybe a little run through of what happens in that pre-install phase.
Got it. I can take this one, Duncan, if you don't mind.
Oh, sure.
So we have a project management team, right, Steve? And what they're going to do is they're going to take care of any particular project from cradle to grave. As soon as that order comes to us and we get it executable, we have our project management team, which is be in constant communication with our customers. There's going to be a set of documents, requirements that are needed for the facilities and utilities. So customers should have all the information in hand well before the machine arrives to their facility.
Great. Okay, so moving right along. This is more about specific applications, and the question, specific applications and specific materials. So question number one is, I need to cut stone and I need to cut metal. Is there any difference in whether I need different machines or different setups, or how do I make that happen? This is someone who's a new water jet purchaser.
Let the applications guy cover that one. Go ahead, Bruno.
Thank you. So yes, as we discussed earlier, right, the jet combination orifice to mixing tube is going to be determined by the pumper we're running, so pressure and horsepower. So once that's set up, that's going to be a fixed item basically. And whether you're cutting stone or steel, glass, any material, you can use the same setup. The only thing that is going to change is the material thickness and type that can easily be changed in our operating system. So you can select either stone or aluminum or steel from a drop-down menu, input your thickness, whether it's an inch or half an inch, and then hit go, and the machine does the rest.
Great. Thank you very much. Okay, so once again, we're going to shift gears and we're going to talk a little bit about software. So the first question is, can we talk a little bit about the CAD-CAM import? I know we touched on that earlier, and our ability to interface with just about any CAD-CAM software. Are there any specific limitations or really onerous requirements, or how flexible is our ability to interface? And why don't we just start there and talk also about, about our nesting software. Have we had any changes to that recently? So just to recap, interfacing with CAD-CAM and nesting software. Who'd like that one?
I guess I'll take that one. Yeah, so our software is very, very friendly and easy to use, right? We have 40 plus years of experience in water jets, engineering, research and development. So all the models and everything that has gone into our software comes from that background. So, if you're looking at 3D modeling, you need no experience. We're going to train your operators and everybody basically in your shop that will be interfacing with the software or the machine to make sure that they can learn the software. And other than that, I think it's as easy as having that geometry, whether it's imported or created in the software, selecting path, and then you can open that file in our machine and it's ready to run.
Terrific. Okay, I have 3 more questions as we approach 10 minutes before the hour here. Question number 1, I think, goes back to the basic setup requirements. And the question is, why is the weight of the machine so important?
I'll take this one.
Duncan?
Yeah, well, not only is weight important, it's the materials that you use to build the equipment. So we build all of our equipment out of one material, which is steel, and we build it big and heavy. The reason for that is it has a lot of thermal mass because of that. And say you're in a shop and especially in the heat of the summertime, your machine's not going to grow very fast with a lot of thermal mass. So you can run all day without affecting your tolerance. The other thing about having steel is that when it grows, it all grows at the same rate. So we can maintain that kind of tolerance with just a simple change of our tool diameter or something like that. So, if you build something big and heavy, it's going to last for a long time. And that's why we do it. Great.
Okay, second to last question is, can we talk a little bit about our what I would call waste disposal? We're getting some questions about, can garnet be recovered? Do I need a permit to throw it away? Is it green? How do we dispose of it? What about the water? Does it get recycled and reused? Can we talk a little about the general use of the raw materials, or not the raw materials, but the utilities, if you will? Duncan, Bruno, who wants that one?
Go ahead, Bruno.
I'll start it. Yeah, so once the abrasive hits the material, it turns into very fine sand. And depending on usage, whether you're running full shifts, it could be 6 months to a year when you have to empty that used garnet from the tank. The water from the tank, the overflow, can go direct into the drain. It's a green process, and the water is going to be as clean as the materials that you're cutting. So if you're not cutting any heavy metals, you can go straight into drain. As far as removing the abrasive, and again, this could be 6 months down the line, a year, and it's going to be dependent on usage. You can do it old school, remove a few slats and shovel some of that sand or used garnet out, or you can get some equipment to help you do this in a more automated way. There are a couple in the industry. We have an ATS. It's a garnet removal that is going to pretty much empty your tank at I would say at a rate of 1 ton per 30 to 45 minutes. And you can move it around so you can be cutting while sucking that material. Once that tank is full, you can bring in your forklift, pick up that bag, and take it straight to the dumpster.
Just a little anecdote on that. Bruno said you can dig it out. I actually have a customer who's had a machine for about 25 years, and for about 22 of those years, he digs it out daily in 5-gallon buckets, just what he needs to. So there's a lot of different ways to do it. I don't recommend that one.
I think that's good advice. Okay, so I'm going to take the last question here. Do we have any specials or offers going on at the moment? Because Duncan was kind enough to introduce at the beginning the fact that this is this is a capital expenditure that requires careful consideration, and we want to provide you with the solution that's best for you and at the greatest value for your business. So to help support that, we try to have offers available in market all the time. They may be different and they may rotate, but the idea is we always want to give our customers the opportunity to either purchase a new system at the greatest value, or for a new Waterjet customer to experience our market leadership and market high quality capabilities and systems at the most economical value. So in that pursuit at the moment, there are 2 things in the works that we can offer you. The first is that we have a system trade-in program available right now. And what that means, if you have an operating Waterjet system that is manufactured by anybody in the world, as long as it is operational, we will take a look at it and evaluate it and determine what credit we can take toward your purchase of a new flow Waterjet. If you would like more information about that, again, I urge you to enter your name and your contact information in the chat field, and we'll get back to you. So that's offer number 1, system trade-in. The other offer that we have in market right now that we welcome you to take advantage of is if you're considering a new Waterjet and you are not certain as to which pump is right for you, depending on the specifications of the system that you order, we're offering an upgrade to the next higher performance level pump that's available and compatible with the system that you would like to purchase. Obviously, this is not a direct X%, but this will be a function of what your entire system configuration looks like. And our customers are telling us that when they purchase a system from us, if there's one thing they could upgrade, they would upgrade their pump. And because of that, we like to offer that at the outset if the pricing and the configuration and your needs are met appropriately. So again, pump upgrade with the purchase of a new system, system trade-in or credit toward purchase of a new system. And then we will be offering a financing program later in the summer, where we work with our finance partners to make sure that if you do choose to finance the purchase of a new system, that you are getting some benefit, whether it's a special low interest rate or a period of grace before you have to make your first payment. This is something we try to do every year seasonally. So whatever of these offers appeals to you, please speak to the sales rep when you have a conversation, and we'll find a way to get you into a Waterjet that's right for you at the best possible price and the highest possible value. So with that said, I would like to close with just a couple of things. You've been seeing the screen for the last half an hour. What's going to happen next is we are going to say thank you very much for your time and kind attention. So many of you have stayed online for the full hour. We really appreciate it. There are a load of questions that have come in, and I apologize that we were not able to get to every single one of them, but we do have them captured, and we will respond to you as quickly as we can. So finally, 2 things. In the next 24 hours, you're going to get a thank you note from us, and you're going to get a copy of this presentation for your freedom to use however you choose. Shortly thereafter, we will be processing all of your questions. Those of you who have given us names, phone numbers, contact information, we'll be distributing to our sales team, and they'll be reaching out to you directly. And then we are going to send you an ebook on the 10 critical factors you should be considering when you're thinking about Waterjet, that gives all the information that's in this presentation, but in more detail, so that you don't have to try to remember the exact talk track. So thank you note, how to reach us, copy of the deck, and then followed by your Q&A and a copy of the ebook. And with that, we say thank you. Look out for an invitation for the next Flow Waterjet webinar coming up in the middle of July. And our special guest will be Jason Marburger from Fireball Tool. Thank you very much. Enjoy the rest of your day.
Thank you.
Thank you.